All right, here's warm-up number 19. We're going to write an equation in slope-intercept form. So slope-intercept form is going to be y equals mx plus b. So my goal here is to figure out what m and b will be. It's going to be, I don't know, like y equals 2x plus 5, something like that. That's not what it actually is, but I got to figure out what the m and b are, okay? So it's going to be for a line that goes through this point. So I've got a through point. And then it's going to be perpendicular to the line y equals x minus 6. Here's how I like to set these up. My old line, that's the one that's right here, okay? My new line is going to be the line that I'm actually writing the equation for, okay? And I know that these are perpendicular to each other, okay? So my old line is y equals x minus 6, okay? So looking at that, I need to find the slope of this. And I can see that the slope is 1 because it's y equals 1x minus 6, right? This is in y equals mx plus b form. So my slope is 1, okay? Now these are perpendicular to each other, so that means they're not going to have the same slope, but they're going to have opposite reciprocal slopes, okay? So if I think of this as a fraction, reciprocal means I'm going to flip the fraction upside down, and then opposite means I'm going to change the sign. Now, when I flip this, I still get 1 over 1, which is just 1. But when I change the sign, it's going to be negative. So it's negative 1 over 1, or just negative 1, okay? So the slope of my new line then is going to be negative 1, okay? My through point, I'm just collecting information about my new line. I already know the slope, which is great, and I still need to figure out the y-intercept, but I do know that this goes through the point negative 9, negative 3. Okay, so yeah, okay, I know that my slope is negative 1, so I'm going to write that like that. You don't really need to write the 1 in, right? You can if you want to. I still need to figure out the b, and that's where this through point is going to come in. So this is going to be an xy pair that's on my line, so I can substitute those values in for x and y into this equation. So yeah, I'm going to substitute those two in because then I'll be able to figure out what the b is. All right. So my y is negative 3. My x is negative 9. Okay, so substituted into that equation right above. Okay, and I'm going to solve this for b. So negative 9, that's positive 9. And now to isolate b, I'll subtract 9 from both sides. So negative 12 is b, okay? So now when I'm thinking about this equation, I've got the two things I need, right? I know the slope, I know the y-intercept. The slope was negative 1, so y equals negative x, and then negative 12 is the y-intercept. So there is a line that goes through this point. You could test it by plugging the xy pair in. And it also is perpendicular to that original line, to the old line. Okay. All right, next up, we're going to solve a system of equations. There's a number of ways you could do this. You could graph the lines, find out where they intersect. You could add these two equations together to eliminate one of the variables. I'm going to use substitution. That's probably the most popular method for solving systems like this. So I've got two different things that are equal to y. That means those two different things are going to be equal to each other, right? Or you can say, hey, if y equals this quantity, well, then I can take that quantity and substitute it into the other equation where the y is, right? So that means x minus 6 is going to equal negative x minus 12. So now I've got an equation with just one variable. And that means I can solve this for x. So let's get those two x terms on the same side of the equation. So I'm going to add x to both sides here, just to move that x over the other side, okay? And so x plus x is 2x. Okay, and then I want to still get my like terms together. I'm isolating the x. So I want to add 6 to both sides. Okay, and then divide by 2. And x is going to equal negative 3. Okay, now, tempting to just move on to the next problem, but I still need a y, right? I'm looking for where these two lines intersect. They'll intersect an xy pair. So don't forget to find the y as well. So I'm going to go back to one of the original equations. It actually doesn't matter which one. I'm going to use this one. and y equals x minus 6. Well, I know what the x is now, right? X is negative 3. And then so I just do the arithmetic there. And then y equals negative 9. So you could write it like this. You could also write it as an ordered pair, negative 3 comma negative 9, like that in parentheses. Okay, there is my solution. All right, and last up, I'm finding the distance between these two points. So I'll call this my first xy pair. This can be my second xy pair. And we've been doing a lot of this, but it comes up a whole lot all year long. We're going to use the distance formula. So I'm going to subtract the two x's. I'm going to subtract the two y's. Square both those quantities, add those quantities together, and then take the square root of the whole thing. Okay. All right. So for x's, I'm going to do negative 3 minus negative 9. You could go in the opposite direction if you wanted. And then for the y's, I'm going to do negative 9 minus negative 3. And again, you could go in the opposite direction. But you want to subtract two x's and your two y's. Okay? All right. So let's see. I got some double negatives here. So I'm just going to change that into a positive. Same thing over here. So that'll give me 6 squared. And this would be negative 6 squared. Okay, now I'm doing the exponents. 6 squared is 36. This is not negative 36. It's negative 6 times negative 6. That'll come out positive, so positive 36. When I add that together, I get the square root of 72, which is fine for me, but this asks to round to the nearest tenth, so you'd want to put that into a calculator, and that's going to come out to about 8.5. Okay, and that's it. See you next time.